Hello everyone. In this video we're going to show how Wavefront by VMware can help monitor VMware's Pivotal Container Service, or PKS. PKS is a production-grade Kubernetes-based container solution that simplifies the deployment and operation of Kubernetes clusters so you can run Kubernetes easily on public or private cloud. Wavefront by VMware is a next-generation metrics analytics tool that handles alerting, dashboarding, and real-time queries to look across your application stack. PKS is one of the applications that you can monitor with Wavefront, and let's take a look at what that actually takes to set up. Right now we are looking at the Wavefront integrations page, and we want to find what the Pivotal Container Service tile is. So coming down to the PKS tile that we can see right here in the bottom left, this is actually supported by the traditional Kubernetes integration that leverages Heapster. So looking at this integration, we can see that it's actually set up. We're collecting data across the node, cluster, pod, specific namespace metrics. So there's a number of metrics across the instance that we're gathering, even in a fairly limited environment that we have present. Right now we're only doing about 10 metrics a second. But looking at the setup for this, I have in another tab, because I've pulled out the personal token that I've used for this. All it takes to actually get this installed and set up is deploying a Wavefront proxy and proxy service, and then enabling the Heapster service so that you can start reporting metrics to the Wavefront proxy service and ultimately the Wavefront metric service in the backend. So these configurations are done for you. All you need to do is simply deploy them and then run the kubectl commands as well that accompany them. And they are already configured to talk to each other. We can see in the Heapster deployment, the tool that is actually doing the metrics collection on our behalf, we have a sync variable reference right here. So that's pointing to the Wavefront service that we set up in steps 1 and 2. And once this is done, we actually have a dashboard specifically for monitoring Kubernetes. And this will give a breakdown based on the nodes, namespaces, pods, individual CPU, disk, network usage, everything down to a very, very detailed level. And we really imagine this as a starting point. Being able to see all of this in-depth information from Kubernetes by itself is very interesting, but likely this is just one piece of your application map. And what I want to show you next is a demonstration of how we can actually take this level of detail and this level of information and start solving real problems with it and start correlating bad actors against a large set of data and have this outlier detection picked up automatically for us. So in this next demo, we're going to be looking at a setup with PKS involved. So we're actually looking at transactions being submitted across an application running on our PKS instance, and then all of the other metrics alongside it. So here we actually just have a backdrop of the different application servers, request latencies, failure statistics of all of our PKS nodes running in a given environment. And what is actually interesting here is we have this rich backdrop of a dashboard that has all of this information about our application running. And on this very first screen, we're actually tracking transactions. And in this case, we can track just these key performance indicators either by using an APM solution, coding them for them directly in your code. Oftentimes it's a very good practice to have your code report directly on what it's doing. So every individual container can actually write at an application holistic level as opposed to just reporting infrastructure level metrics. But in this case, we're actually looking across transactions per second that's being processed by our app as a whole. In this case, we can see that there's this red shaded area, and this is actually an event that happened. This is an alert that fired and notified the team that we have lost some transaction rate in this case. So the first thing that we typically do in this case is start profiling this by different tags of the data. So the first thing that we can notice is that all of the customers, we're doing a breakdown by customer right now, all of the customers seem to be uniformly impacted. And this implies that there's no hotspot or demand tied to an individual customer. There's probably a different pattern in here. the next obvious thing that we can look by is the application server, the actual nodes in the PKS environment. And we can see here there's a very obvious outlier in this case that application server 5 is failing, and this is the bad actor. A lot of us are happy just restarting that pod or node and hoping that it heals, or even just understanding, do we need to scale this up or let it die? But that's still a very optimistic approach to this. It really, in many cases, you need to understand exactly what went wrong, what the problematic process leading into that was, so you can prevent this from happening next time and you don't get into this state of cascading failures, constantly exploding out in scale and seeing failure kind of cascade throughout. So what we're going to look at here is, we know App Server 5 is the particular node with which we're struggling. And this view here is everything being collected on this box. This really noisy, ugly chart represents all of the data that an operations or developer team would need to sift through to understand what problem was actually was causing this transaction rate dip. So what we know about this data is there is a transaction rate that's failing. So this is our bad data shape. This is what we know is problematic in our instance. And what we can do is actually correlate this bad actor against all of that noise, that star query that we saw before on that machine, and pull out all of the relevant other systems in this case. And we're actually doing an absolute correlation, so we're looking at things that are positively and negatively correlated. So we can see that this silver line represents available memory on the machine. And that is dropping exactly hand in hand with our ability to serve transactions, which is that blue line. We can also see the the orange and red lines are climbing in the opposite way. And those represent log errors and garbage collection, respectively. So just by doing this correlation, we've been able to increase our understanding of the problem from just, there was an outage, let's restart the machine, to very explicitly at 7:10, there was significant garbage collection process, and at 7:08, there was a steep memory consumption event. So if we want to actually go and hand this off to another tool, we can hand this off via an external link to either a logging or networking or other debugging tool that can help us dive down and find the exact line of code that was executing to cause this problem, or the data shape of request that came in that was preceding this bad data shape immediately beforehand. But we were able to very quickly drill down the nature of the problem and the scope of the problem, all in a few clicks. Thank you very much for tuning in and seeing how Wavefront can help augment and speed debugging over your PKS environment.